Good day, everyone. This is lesson 2.2, Types of Organic Reactions. This video is based on the PSHS Chemistry 3 module lesson 2.2. For this lesson, we have the following targets. First, to identify and describe the different types of organic reactions: addition, substitution, elimination, hydrolysis, and condensation. And number two, to predict and write the products of an organic reaction based on these patterns of reactivity. So in general chemistry, from your grade 9, you have already learned about the different patterns or types of reactions. So we have combination, decomposition, single replacement, and double displacement. The general form of these different types of reactions are shown here. So for a combination reaction, that's the combination of one or more substances to form a new substance. And then for a decomposition process, you have one substance breaking apart into two or more substances. And then for a single replacement reaction, you have something that looks like this, where one part of a compound is replaced by another. And for a double displacement reaction, this is like the exchanging of partners between cations and anions, or any two parts of a compound. So knowing these patterns allow us to predict the products of chemical reactions and also to write complete balanced chemical equations. For these three, these are also other forms or more specific forms of chemical reactions. So we have the neutralization or acid-base processes, where you have the reaction between an acid and a base forming a salt and water. Also precipitation processes, where you form a solid precipitate out of a solution. And a redox process, where you have the simultaneous reduction and oxidation process, or the exchange of electrons. So in organic chemistry, similarly, recognizing reaction patterns can help us predict the products of an organic reaction and also to write balanced chemical equations. So without further ado, we will proceed to the Ignite section, where we will be discussing the different types of organic reactions. First, we have the substitution reaction. So substitution happens when an atom or group of atoms attached to carbon is replaced by a new atom or group of atoms. For example, here we have the general form where Y, initially attached to carbon, will be substituted by Z. So this will be the product. As you can see, it's simply that Z has substituted Y in the original structure. So notice that a sigma bond is broken on carbon and a new one is formed at the same carbon. So this is the sigma bond that has been broken, and then another sigma bond is formed on the same carbon, so that the number of bonds around the carbon remains the same. In this case, it's only 4. So in this reaction, carbon is electron deficient because it is bonded to an atom represented by Y, which is more electronegative. So Y is more electronegative compared to carbon, therefore it pulls the electrons towards itself. However, Z is a good nucleophile, meaning it has an excess of negative charge, or it is more attracted to a positive particle, which in this case would be this part, carbon. Therefore, it is going to displace Y and replace the position of Y, and therefore Y becomes the leaving group. So here's an example of a substitution reaction. In this case, we have this structure. Notice that the Y in this case is iodide, and then the Z particle or the nucleophile is chloride, and it is able to displace or substitute iodide in the structure. Notice also that chloride in this case is more electronegative compared to iodide. And then also here we have another example. So where the methoxy group is able to substitute chloride in the structure. So it is more nucleophilic than chloride. Okay, so in this example, methoxy ion replaces chloride. Next, we have elimination reactions. This is where an atom or group of atoms on adjacent carbons leaves the molecule. So we start with a structure where we do not see any pi bond. So these sigma bonds will be broken. And a pi bond is formed. So just imagine that in this structure, each of the bonds have 2 electrons or made up of 2 electrons. So these will be cleaved, leaving 1 electron from on Y, 1 electron on Z, and so that they can form their own bond. And then we will be left with 1 electron here, another electron here, forming the pi bond. Okay, so what I have explained to you is just for easy visualization of what happened in the bonds. However, whether whether the electrons have been distributed equally between Y and C or carbon and between Z and carbon will be discussed specifically depending on the specific situations or mechanisms that would happen, which will be discussed to you later in succeeding modules. So notice that in this case, 2 sigma bonds have been broken and a pi bond is formed between the 2 adjacent carbons. By the way, this is the wrong symbol, so this is the sigma bond. So these sigma bonds are broken and a pi bond is formed between 2 adjacent carbons. So often, Y is a hydrogen atom and Z is a more electronegative heteroatom than carbon, like a halogen. So this could be hydrogen, this could be, say, chloride, and if the sigma bonds are broken, then this would be hydrochloric acid. So examples, yon. So this was what I was saying. In an elimination process, notice that you have displaced hydrogen and chlorine forming hydrochloric acid, and you will have the formation of a double bond here. Okay, HCl is eliminated, and in the next example, you have H and OH. Therefore, you'd have an alkene and the displacement of HOH or water. Next, we have addition reactions. This is where a new atom or group of atoms is added to the molecule with a pi bond. So it's like the reverse of elimination reactions. So here we have a pi bond, this bond which is broken, and this bond here would also be broken so that each of these atoms can attach themselves to the now available carbons. So a pi bond is broken and 2 new sigma bonds are formed on the adjacent carbons. So this is the pi bond that is broken and the 2 new sigma bonds formed on the adjacent carbons. And this is the reverse reaction of elimination reactions. So again, here are some examples of addition reactions. So here we have an alkene, and then we're going to add HBr. So there, H and Br atoms are added to the structure. And then for the other example, we have HH or H2 being added to the double bond. So instead, we have a saturated hydrocarbon with two hydrogens attaching themselves to the previously double bond. Okay, so aside from those three general types of organic reactions, we also have some organic reactions with more specific names. In this case, hydrolysis. So here, hydrolysis is the chemical decomposition of a molecule due to the addition of water. So in this case, we could have a large molecule and reacting with water to form smaller molecules, which were basically split from the larger molecule. So the one small molecule would have an OH attached to it. Another small molecule would take the hydrogen part of water. So there. So this is when an organic molecule reacts with water to form two or more products. So in a way, you can say that water has split or has caused lysis to the molecule. Therefore, you have two smaller products. So please do not be confused with this oval over here. So this is just to show that this comes from water, but these are already two different structures. So the OH part belongs to this molecule. The H part already belongs to this molecule. Okay, so they're not together anymore. So as an example, here we have the structure, and then if it's going to be lysed by water, then okay, so we are retaining this part, and then this has been replaced by OH from water, and then for this part, okay, the other part has been replaced by hydrogen. So now we have two smaller molecules coming from this larger molecule. Next, we have condensation. It's the combination of two small organic compounds to form a single, larger molecule along with the release of a smaller molecule like water or ammonia. So here's the small molecule. This is another small molecule. And then we have an OH coming from one small molecule and the H coming from another. Now, these two would give off water, and it's basically going to connect two small molecules together. So specifically for this process, because water is released in a condensation reaction, then we call this dehydration. It's a condensation process, but specifically, if we would like to specify that water is the one that is being released, then it's called a dehydration process. But in general, condensation reactions can involve the release of a smaller molecule like ammonia, not just restricted to water. So here's another example. So we have two smaller molecules, and then there's an H part and an OH part. So this is going to form water, and it will connect specifically between carbon and oxygen, because that is where the OH and the H from water comes from. So here, carbon. So the carbon here gets connected to the oxygen of the other molecule. So that's why you have a CO bond there. Okay, so the alcohol and carboxylic acid combined to form an ester, and water was released. So How do we know exactly that in this process, for example, we that it's going to be like connected here? And how do we know that, of course, in this case, we only have this OH part here. So how do we know that the other hydrogen that's going to be cleaved together with the OH part here is this, and not any of the three hydrogens here? Okay, so that is going to be discussed in more detail in future modules. However, just as a simple explanation, this hydrogen This hydrogen here is easily accessible or more easily cleaved compared to the other hydrogens here, mostly because of the presence of oxygen, which is more electronegative. Next, organic synthesis reactions are basically combinations of all of the different processes. So, of course, it should lead to the synthesis or the formation of a desired product. So, for example, in the synthesis of cyclohexene from cyclohexane, in general, that would be this process. Cyclohexane forming cyclohexene. So notice that if it's going to be just a one-step process, then what kind of process is it? It's going to be an elimination process. However, in reality, it is usually carried out as a two-step process. First, by substituting cyclohexane with a bromide branch, and then finally by eliminating HBr. Okay, in this case, it has formed H2O and KBr because the reagent that was used was KOH. So from this structure, we have eliminated and to form this double bond. Okay, so again, for organic synthesis reactions, you basically have multi-step reactions, and they may have different types. They may be made up of different types of reactions. Again, why was this not done as a one-step process? Of course, in the real world, this may require probably more energy or more expensive reagents compared to doing this synthesis as a two-step process. Okay, so that ends the lesson. Proceeding to the navigate part of the module, classify each transformation as substitution, elimination, or addition. So for letter A, take a look at what happened. The OH part has been replaced by bromide. Next, for letter B, at what happened here was here a double bond. The double bond has been removed, and then for letter C, what happened? There's a hydrogen here which has been replaced with a chloride, and then here, so this was removed, and one hydrogen here was removed to form the double bond here. Number 2 is the following reaction, a hydrolysis or condensation reaction. So again, a hydrolysis reaction would cause a lysis, or the breaking apart of a larger molecule to form smaller molecules. A condensation reaction would be a formation of a larger molecule. Number 3, complete the following chemical equations. Predict and draw the structure of the products of the following reactions given the kind of reaction. So here, we are supposed to have an addition reaction, and we would just have to add bromine atoms on both sides of the double bond and just check that there would be a total of 4 bonds around each carbon here. For letter B, this is a substitution process. So this would be the only part here that we could substitute would be here, bromine. Okay. So for this part, because you're replacing bromine or bromide, that would be your leaving group. So it would have to be substituted with a different, with the same kind of ion. And then for letter C, you have this, and then we're supposed to do elimination. So for the elimination process, since chloride here is found in the middle, okay, so you're asked for 2 answers, 2 products. Okay, these are fairly straightforward processes. Yeah. So I think you'd be able to manage answering the navigate part. And finally, to not everything. So we have the types of organic reactions: substitution, elimination, and addition. So these are the 3 major types of organic reactions. And then specifically, we also have hydrolysis and condensation. So I hope that this video has helped you digest Module 2.2 or Lesson 2.2. Thank you, class, and goodbye.